just ignore it. I'm gonna go. She's present. Okay. Going on the quiz right now. So, I have to leave early again at 45, and it sounds like Annie does too. So hopefully we'll be able to get all this done.
Okay.
I'm just pulling up the quiz right now. I didn't really have issues with the homework, so it shouldn't be too bad.
Yeah.
It was just different, that's all. Quiz. Okay. I'm pulling it up right now. True. Okay, do you have it pulled up?
I'm pulling it up right now.
Okay. Just let me know when you're there, and then I'll start reading it out loud.
Okay, I've got it open.
Okay, so we have all those links up there. Okay, in a NOVA hypothesis test, we reject HL, so the null, when there is sufficient evidence to indicate at least one mean is different from the others.
True.
True. Yeah. Okay. What requirements need to be checked when performing a NOVA hypothesis test? So data is normally distributed.
Yeah, and the variances
Are
I think.
No, in the textbook, then it said that you need the data are normally distributed in each group, and that the largest variance is not more than 4 times the smallest variance.
right.
So they don't need
Okay.
And then it's not the sample mean that needs to be positive, it's the F score.
Right.
Right, yeah. So question 5. To check if each group is normally distributed, do the following. Construct a scatter plot of the data in each group, construct a histogram, and construct a QQ plot. So it would be A and C, I believe.
We can only select one.
Uh,
I think it's just construct a QQ plot.
Yeah. Okay. You're right. I just remember using both, that's all. Let's see. Okay, question 6. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean, and each group has the same sample size.
It's the second option.
The largest variance, yeah. Okay. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? 2-sample t-test between every pair of samples.
This is a weird question.
It is. I don't know if I understand.
I mean, like, I get it, but
I think it's 6.
6?
Yeah. Well, because we have the samples listed for the pairs of samples, and then there would also have to be 1, 4, 2, 4, 3, 4.
Yeah, I got 6.
Okay.
Okay.
I think it's weird that it's asking us that though.
Yeah.
Yeah.
Okay, so it looks like we're gonna have to open up the applet. So,
Not that
sorry, not the applet. I meant the data.
Yeah.
So I'm gonna just open that up real fast, and then I'll read the question. Okay, mine's pulling up. Okay. Second, I'm just so we click one way ANOVA test and put that in.
Mine
there.
is still opening.
It's no problem, we can wait.
It's weird it doesn't have the factor though.
That is weird. What's up with that? Oh, you know what I think we have to do?
Do we have to create something?
No, we have to go into the transform the automatic recode for the footwear.
Automatic recode. Okay. Footwear. So give it a new name, I guess. Just do- Okay, try this again.
Yeah, that worked.
Works.
Mhm.
Okay.
Sorry, mine is still opening.
Then mine.
That's right. And then, okay, so go back into the ANOVA test.
Okay.
Wow.
Sorry, compare means that's what I meant to do.
Okay, and then options.
Oh yeah,
And
descriptive.
hit descriptive, yeah.
Forgot about that. Okay, do you have it all up, Sarah?
No, it's still opening. It's just taking a really long time.
That's okay. So Annie and I noticed that you had to transform and recode for one of the categories. Just a heads up.
Okay.
Like before.
Yeah.
So the question is just asking what the smallest variance.
For the 6 groups. So would that be the then what are we looking for? The minimum?
Maybe the mean, but I'm not sure.
Smallest variance. I just don't remember that being calculated into a number. I didn't do that in the homework. So just question, Sarah, I know you don't have it open yet, but it's asking like, what is the minimum smallest variance for 6 groups? Do you know
Yeah.
what number we would be looking for? Like, because once you get to descriptive statistics, there's the mean, the standard deviation, the error, lower, upper, minimum, maximum.
I think it's just the lower.
The minimum?
The lower bound, or?
Yeah.
I mean, I guess we can just try it and then you can always retake it.
And do something different. So then it would be 27.4. I mean, AP.
I really think it's the mean.
You think it's the smallest?
Yeah, because the next question is asking for the maximum, the largest variance for the 6 groups. And
It
like,
does make sense.
yeah.
Okay, let's do that then.
So the first one would be 29.45.
Yeah.
Did yours open yet, Sarah?
No, it's still loading.
Okay. And then the maximum would be 35.25. Did you get those numbers, Sarah?
No, my whole screen, I can't use it when it's
Okay.
logging in.
Ten is another question. The test for equal variances is satisfied for these data.
Oh, did you start the recording?
Yeah,
Okay.
I did. It's recording. I guess we could work on creating. The test for equal variances
Wait.
is satisfied for this data.
Hold on.
Am I missing something? Because I don't remember.
No, so to do that, then it's,
The greatest.
you know what? Okay. I literally had it written down in front of me. It's not the mean, it's the standard deviation.
It's the lowest standard deviation.
Mm-hmm.
That actually sounds familiar now. So it's 5.216. Well, we were wrong. It's the lowest standard deviation.
Okay, so that's 5.316.
Yeah. 5.216.
Yeah, 5.216. And then the highest would be 7.291. Which makes more sense with the next question that it's asking us. So the test for equal variances is satisfied for
So that would be false because if you, the way you check that is multiplying the smallest by 2. And the, oh wait,
no,
just kidding,
true.
it's good. Yeah, true.
It would be true.
Right.
Because it would be larger.
Yeah,
So it still has not brought up the data for me.
I'm
Okay.
sorry. Do you want us to keep working on it and just tell you and wait and
Yeah, let's keep working on it because you guys have to leave.
okay. Yeah, just let us know when you pull it up.
Okay.
So for 11, we're constructing a QQ plot.
Okay.
Let's see if I can see
I
time.
don't remember how to do that.
Wait. Okay. Explore. And then
What's right there?
yours is different than mine is. I'm trying to remember.
Okay, mine just came up.
Okay. Check it.
Wow, that one is not quite normal.
Mine's still processing. Okay.
Yours looks different than mine. I think yours is right though. No, it's not normal.
No, it's not normal.
Those aren't normal.
It's not normal.
Yeah, so it would just be false.
Although, yeah, okay.
Can you show me how you did yours really fast? So you go into
Yeah,
analyze.
it was weird. It's descriptive statistics, explore, and then you have the kicking accuracy in there, and then the type and the factor, and then options. I think. No, sorry.
And then just okay.
Plots, sorry. You go into plots, and then you click normal plots with tests. And then continue, and then okay. Yeah. Okay, are we good to move on to 12 then?
Yeah.
We put false for number 11 because not all of our QQ plots were normal. So perform a NOVA test in SPSS and observe the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data? How can you just remove that data? This is what Riley was talking about yesterday that was sucky and weird. I don't know how to do that, honestly. Do you have any idea how we would do that, Sarah?
No.
So
That's weird to me.
okay, I think I understand.
Because don't we need the socks? Well, I mean, sorry, there aren't socks on there.
Well, it looks like Annie's deleting it and having no issue. I wonder if it'll work for you. Did it work?
Yeah.
Oh.
So it's 0.309.
So it's 0.309 for 12. And I mean, Annie was able to go in and delete the SOC data to perform that thing. So I guess it's possible.
Okay.
So question 13, the test statistic for ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
It's always to the right.
The right.
Okay.
So somehow I missed question 10.
Oh, okay. We put true.
Okay.
That it was satisfied.
Okay.
Do you remember how to get that?
So we just use the times the lowest by 4, right?
By 2 is what we did.
That's what it said to do in the video.
Yeah, it said to do in the video was times it by 2, and then
if the one that was originally larger is less than,
then it's okay.
Yeah.
Okay. So let's see. Question 14. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available, blah, 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 then use it to answer the remaining questions. So, looks like we're going to be doing another data set.
So Annie, could you explain how you deleted the sock data?
Yeah, so I just had the file opened up and I just highlighted all of the socks and like the files that, or the columns that were related to the socks. So like across sideways and just hit delete and it worked for me.
Well, because I don't have any data on socks.
It's down at the bottom.
Yeah, you have to scroll down for a little bit. I didn't try it, I should have, but it looked pretty easy.
Okay. Okay, yeah, I see what you're talking about now.
Oh, I keep forgetting to do that.
Would you put both of these here?
No, I think you put sodium in the.
No, groups down here.
Oh, because that's the type. Yeah, you're right.
I'm just gonna print both.
Did it work?
Yep.
Okay. We need to do that over again then. Okay. Sorry, I'm just recoding real fast.
That's what I'm doing too.
Type. Okay, well, I guess I'll plot something else. We'll just sleep. I don't know. Okay, analyze, compare means one way. Okay, that's weird. I'm gonna put that and that. Factor, options, descriptive, continue.
So when we're putting it into Explore, we're just putting the me independent, right? And then the others are empty.
I mean, the type should always go in the, oh gosh, I need to go look at it again.
I can't get mine to work with QQ plots.
I put the calories and the sodium in the dependent, and then in the factor, I had the type, the one that I had to rename.
Okay. Well, just because the question, it isn't asking us about a certain one of either calories or sodium.
Yeah, I mean,
I think it's just all of them total.
yeah.
Okay. What did you get for your QQ plot then?
Let me try and keep it. Okay, what did I do last time? Descriptive statistics, explore. I'll try and do that. So wait, dependent would be then the factor would be that. And plots. Do you click normal like T?
Yeah. And it keeps trying to give me a box plot.
Second. I got it.
Yeah.
It's weird.
That's normal.
So they haven't been met then.
Mm-hmm.
Well, it says to assume each group's coming from one, we cannot assume that the variances are equal. Were you able to get the QQ plots?
No, it's saying, well, it's just not working.
It's not working for any
So I
either.
think it would be the third.
Okay.
But some of mine were normal and some of mine weren't. So we're thinking that it's the third one or the
So
fourth.
they're the third or the fourth. I don't know.
So the third or the fourth, the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal, or the assumptions have not been met. It is not safe to assume each group comes from a normally distributed population, and we cannot assume the variances are equal.
Okay. Okay, mine just started loading, so it's showing me the QQ plots. And yeah, they don't look.
So
No.
do we need to check them?
Dang it. I guess.
What do you think on 14, Sarah?
The third option.
Third.
Okay. Why do you think it's the third one?
Well, because the assumptions, the QQ plots show that the data isn't normal,
Uh-huh.
so we know that the assumptions haven't been met.
Right. The difference between the third and the fourth is one, you assume the variances are equal, or one, you cannot assume the variances are equal. That's the only thing that I'm confused on. But
We can always retake it.
we can always retake it. Okay. Question 15. Riley said this was a trick question, so she said to really read through everything. I don't even know if she used SPSS or not for this, so
Okay.
run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074 and P equals 0.000. What conclusion can you draw? A, we have sufficient evidence to claim that all three hot dogs types have the same mean number of categories. B, we do not have sufficient evidence to reject the claim that all three hot dogs types have the same number of calories. C, we have sufficient evidence to claim that all three hot dog types have a different mean number of calories. And D, we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
I would say that we do not have sufficient evidence.
Why?
Because the degrees of freedom, 2 and 51, that means that the populations that we're drawing from are 3 and 52, and
Right.
3 isn't big enough to get the normal distribution.
Yeah, I think you're right.
Okay.
That makes sense. Okay. 16. Now let's examine the sodium levels. Construct QQ plots of the sodium levels for each of the three type of hot dogs.
Hold on, that makes it sound like we were only doing the other category before. Did it say that?
Well, we were doing the calories data
Okay,
in
and
the previous questions.
so when you did your QQ plots, were they only, some of them were not normal still? Or were they all normal? For the calories.
Some
They
That's the
were
same.
not all normal.
For the calories,
Yeah.
we're good then.
Well, I mean, they're very close. I guess the thing is the definition that we were given of what's normal is kind of vague.
Sorry, I'll be right back.
Can I look at your QQ
Yeah,
plot?
just look. I need to go get my charger. You can mess around with it.
Where are they?
Maddie's computer is so weird. I don't know how to do this. I don't know how to work your computer, Maddie. I can't find your SPSS. I just wanted to look at your computer. Okay, so it did look like a couple of the ones for calories were not normal. And then the ones for sodium also have a couple that are not normal. So then, would we do the same thing for 16, assuming that they're not?
So they're not met, but the variances are still equals. Is that what you're saying?
Yeah, I think so. Okay, so question 17. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all groups. What is the p-value for this test? So, looking for the p-value. Sorry, I'm just trying to find that value.
So it's 0.179.
Yeah. Yeah, it's 0.179. So 0.179. Okay. So we're gonna move on to question 18 if everyone's okay with that.
I can't find where you're getting the 0.179.
Okay, so they have the little box near the top. It's under the ANOVA title.
And it says like between groups, within groups, and total.
Yeah.
And then over on the far right side, then it says SIG dot, and that one's the p-value.
Yeah. Were you able to find that?
Yeah, so how do we know that it's the p-value of the meat though?
We're just looking at the p-value for the sodium right now.
Okay. Does that make sense, Sarah?
Yeah, I don't have 0.197 for that though.
179.
0.179.
Oh, I don't have that either.
I don't know then.
That's what we've both got.
Yeah, we both got that answer.
Can we do the last question really fast because they've got to go?
Yeah, let's just do the last question really fast, Sarah. And okay, so because I have to go too, actually, unfortunately. So,
Okay.
what conclusion, can you draw about the mean sodium levels of the 3 types of hot dogs using the significance of 0.05? So we probably need to use the, do we use the 2 times thing or no?
No, that's right. So right now we're just looking at the 0.179.
Oh, okay.
And what was the number we got for 17 again?
0.179. So let's see.
So I would say that we don't have sufficient evidence because it's over 0.05.
Right. Well, what was the rule? I can't remember.
So I think the answer would be option 4.
You mean we have sufficient evidence?
I mean, sorry, option 2.
Oh, you're good. I'm just trying to remember because I feel like in the homework.
Well, okay, so the null is always that all the means are equal. And we would fail to reject the null because this is higher than A.
So then we would have sufficient evidence?
Well, the p-value is over the level of significance.
Right, so we fail to reject the null.
Yes.
Okay.
Let's just go with that.
We'll just go with that and just submit that. See what happens.
Should one of us submit it first and then we can see?
Oh, looks like Annie did. How'd we do?
Okay, we got like 73.35. So I'll just have to come back to it later though, because I've got to go.
Yeah, so we got a C on it. I can look over it for a few minutes if you want me to, because I have about 5 more minutes that I could be here.
So what were did you see what questions we got wrong?
Okay, so question 4, what requirements need to be checked when performing a NOVA hypothesis test? We only got one of those right. So I don't know, because we got it right that the data in each group is normally distributed, but I think we needed to click on something else. Either the means are all positive or the variances are equal. I think the variances need to be equal because that kept up coming up and
I think so too.
everything that we were doing. So that would be a simple thing to fix. So we were wrong about the smallest and the largest variance. I guess it wasn't the standard deviation. So I don't know, maybe you were right, Sarah. Maybe it was I don't know what it would be instead of that. But we got that wrong. We got 8 and 9 wrong. And we got 11 wrong. The constructing a Q-plot for each of the samples. We got 12 and 13 right. We were wrong.
Okay, so then 11 would have to be true, right?
11 would have to be true. We got 14 wrong. So the only thing that I can think of is that it would be D, unless we're completely off the mark with that. We got 15 wrong as well. We got 16 correct, 17 was correct, and 18 was correct.
Okay, so with number 14, I think it is option 2 because if the QQ plots, it told us that we got it wrong on that, and so the QQ plots would be normal. So we would, in the options, it would be a normal distribution, but we can't assume the variances are equal, I think.
That makes sense. I think you're right. So 14 would be B probably. So that's helpful because I think there's a couple other things we'll have to figure out probably on our own, but knowing that other thing was wrong, I think helps with this. So I'll just have to write that down.
So what were the other questions after 14 that were wrong?
15 was wrong. And sorry, 1 second. I'm just writing down the 14. And we didn't get anything else wrong after that. So 16, 17, and 18 were right, but 15 was wrong.
Okay.
So it seems like we got all those types of questions wrong about finding the evidence and stuff. So I guess we need to understand that concept a little bit better.
Okay.
But I don't know. I don't know what we did wrong for 8 and 9. That one's kind of confusing to me because you can test out a lot of different things for that. So I might probably the best thing to do would probably be going back in the textbook and seeing if they have any specific information on that, because that might be just something that we need to be reminded about.
Yeah.
And then probably putting in the variances are equal as well for question 4. So, and hopefully that'll get a better grade based on those. But if you don't have any questions, then I guess we should go. Is there anything else you want to talk about before we leave?
No, that was it.
Okay. All right. Thanks, Sarah.
Okay.
Bye.
Bye.